I'm Anil Kumar, and here is a test question for you. The question here is Peter went to Victoria, BC to go whale watching. Over a period of 2 days, he recorded the amount of whales he saw in the chart below. Use this information to answer the questions below. Hours observation 3, 6, 12, 24, 48, and so on. And number of whales 6, 15, 33, 69, and so on. The questions are complete the chart above and graph the data. Part B is what is the algebraic expression, and part C is how many hours will it take to watch 60 whales. So you can pause the video, copy the question, solve, and then look into my suggestion. Well, I have a very small graph paper here. You can make a bigger and a clearer graph when you do this exercise. So let's begin by discussing how to solve such a question. So what we are given here is a table of values. Number of hours related with the number of whales watched. So for 3 we have 6, 6, 15, 12, 33, 24, 69, 48, something, right? And that is how the pattern goes. First part is complete the chart below. That means we need to figure out what these numbers should be and then place this data on the graph paper and sketch your graph. So finding these values, what you could do is you could see the intervals for the input separately, for output separately. That could be easier at times. What we observe here is 3, 6, 12, 24. So 3 times, it is doubling kind of, right? 3 times 2, 6 times 2, 12 times 2, so 24 times 2. So the hours of observations are doubling. So if I do 48 and multiply, so it is times 2, right? So it is times 2. So 48 times 2 is 96, correct? So we could get a value like this. Let us see the pattern for number of whales. It says 6, 15, 33, 69. Okay, so 6 times 2 is 12, but it's 15, 3 more. 15 times 2 is 30 and 3 more. That works. So if I'm going from here to here, it seems to be times 2 plus 3, right? So that is how it is. So we can actually figure it out. So we could multiply 69 by 2. So let me do that. So 69 times 2. 70 will be 140, so 2 less, so 138, and we'll add 2 to this. So when we add 2 to this, we get 140. So this number should be 140, correct? So I'm sorry, we have to add 3 to this. This will be 141, correct? So the pattern is double the number and add 3, right? So 141 is what we get here, right? Twice, and then again we'll apply the same strategy here. We will double this number and add 3. So 141 times 2 will be 282, and when we add 3 we get 285. So these are the numbers of whale which you can see in this rate. Now these are your data points which you can place on the graph. Whenever you draw a graph, it is kind of important to label. On the x-axis it should be hours watched, and that is in hours of course, and the number of whales. So here we have number of whales, correct? Correct. So the graph will be called number of whales versus time, right? So which is, we say number of whales versus time. So more you watch, more whales you see. However, this expression is, we need to still find how they are related, right? So that is the next part. What is the algebraic expression? Okay, let us first try to see how to sketch this kind of a graph. Now as you see, the data is not very easy to plot. The x values, I should say the independent variable time, which is in hours, is from 3 to 96. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if I keep 10 as a unit, I could go till 100. So that kind of works, okay, 100. So I could do this. I could take 10 as each individual, but as you notice, the number of hours is multiples of 3. So instead of taking it as tens, well, you could take it as 10 also, not a problem at all. But it would be good if I take it as multiple of 12, right? So it is 120 for me. So I could take each unit as a multiple of 12, correct? So I'll do that. So for me, I will take each unit as 12. So 12 times 5 is 60. So 1, 2, 3, 4, 5. So this will be kind of 60 for me. And 1, 2, 3, 4, 5 will be 120 for me, right? So that is how we have number of hours along the x-axis. Now the y-axis increasing up to 285, so 300, right? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, say 10. So 30 each, right? So if I take kind of 30, okay, so let it be 30 each, what to do, right? So we could have 30 each. So that is how we could say, let it be 30 each, and then we'll go up by that method. So let us plot the points now. If I'm taking each unit along the y-axis 30. So 3 is quarter, right? So 6 is half, 3 is quarter, and for 3 it is 6 is my number of whales. So 15, and this is half of half. So this point is kind of like here, right? So that is where I get my point. For 6 it is 15, so it's almost half of half, right? So that is the point, correct? Now for 12 it is 33, so 30 is slightly more than 3, so we get another point here. For 24 it means I have to go 2 divisions, and for 24 it is 69. 69, this is 60, and that is kind of 69, correct? So we get the third point for 24. Then 48 means 4 of these, right? So 1, 2, 3, 4, so that is 48. 140, so we go 30, 60, 90, 120, 150, so it's less than 150, so kind of here, do you get it? So these are my points which I am getting, and similarly for 96, 96 will be, this is 48, so 4 more, 1, 2, 3, 4, so somewhere here, and 96 is 285, right? So 10 will be 300, so let's go 300 first. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, that is 300, but 15 less, so kind of here. Do you get the point? So we get a point here. So these are the points which I have drawn approximately. Well, this is, as you can see, very approximate, but I think it's pretty close to the real situation, right? So now you can join them. So I'm just joining them with the help of a straight line. So this is my straight line. Of course, this is not 0. I mean, it is slightly kind of here. We don't know what it is, so we are starting from 3. Okay. If you don't go, you don't watch. So if you don't go, you don't watch. But the idea here is we don't start from there. So we are starting from whatever is given to us, this point, and we are kind of ending it there. But we say that this pattern is followed, so we can always extend it to some extent. Okay. So that is how we can get our graph. Now the idea is how to write an algebraic equation or an expression for this particular situation. That is part B. For that we need to relate how is our independent variable varies, and how independent variable and dependent variable are related. So let's see, 3 times 3 to 6, it becomes double, that's okay. 6 to 15, if I double 6, I get 12, not 15. Oh, that doesn't work. So doubling is not really working. 12 times double is 24. 36 is a very high number. So by doubling, it is not working. But 12 times 3 is 36, right? So it is 36. It is 36, but 3 less. Do you see that? 33 is 3 less. Okay, let's go back. 6 times 3 is 18. 18 and 3 less is 15. That works. 3 times 3 is 9, and less 3 is 6. That works. So we could write an algebraic expression as 3 times n, and then take away 3. This is one way of doing it. Do you understand? This is one way of doing it. Now it's kind of difficult since these are not constant values, so it becomes kind of difficult at times to relate. But the way I did it is simpler method to get to the situation, right? Now, so I'll suggest that you could actually do it the way I did. Try to find a relation between the two variables, right? Number of hours in this case and number of whales. So what we get here is 3 times the time, take away 3 gives us the answer, right? So that is how we could figure it out, right? Now it was important to do something like this since the variation in time is not constant. It is not increasing by 3 each time, right? So we are not able to do with the standard way. Anyway, you do understand. It is a very good thinking question. Now the question is, how many hours will he take to watch 60 whales? That means I have to equate this to 60 and find n. How do we get that? So we could do it by systematic trial. I could take n as 20. If I take n as 20, then what? So if I take n as 20, I can calculate this as 3 times 20 minus 3. 3 times 20 is 60, 3 less. So 3 times. So that means it is one more than that, right? So for 60 it could be 21. So I'll try 21. 3 times 21 minus 3. So that is 63 minus 3, and that is 60. Correct. So we get our answer, and the answer is n equals to 21. N equals to 21. And the method which we applied is called systematic trial method. So we use systematic trial method to find our answer in this particular case. And it is very effective. You can see how easily we could get our answer. I hope that is important to understand. Go through this video once again. Subscribe to my videos and learn a lot. Thank you and all the best.